Hello, welcome back to Chapter 6, Section 6, where we're going to be solving systems of linear inequalities. We're going to draw attention to something that might happen sometimes. Sometimes the boundary lines are going to be parallel. What does parallel mean? Basically, it kind of means they go in the same direction. Mathematically speaking, or geometrically speaking, it means that the two lines are never going to intersect. Not on the right side, not on the left side, not above, not below, never. They're always going to keep the same constant distance between the two lines. They're never going to get closer, they're never going to get farther away. And to be honest, that doesn't really affect any of the things that we're going to do to graph a system where the two boundary lines are parallel. Everything else is going to be the same. The only thing is that we want to draw attention to it just because it sometimes causes a little stress when you see it, I suppose. So we'll show you how this is going to work. I'm going to still use my green and red markers here. So for the green one, my boundary line is going to be y equals 2x subtract 3. My y-intercept is negative 3. That's right here. My slope is going to be 2, which is 2 over 1. So I go up 2 spaces, right 1. Up 2 spaces, right 1. And I do that until I go off the grid. And I also go the other direction, down 2, left 1. And it's also going to be like right here. I'll go off the grid. Now, is it solid or dashed? Both of these are going to be dashed. So I'm going to draw some dashes here. And do I shade above or below it? Well, let's check. Let's try 0, 0. Is 0 less than 2 times 0 subtract 3? 2 times 0 is 0. 0 subtract 3 is negative 3. Is 0 less than negative 3? No, it's not. So let's try a point on the other side. Let's try this one. X equals 2, y equals 0. Is 0 less than 2 times 2 subtract 3? 4 subtract 3 equals 1. 0 is less than 1, so that's true. So I'm going to shade below. And it's going to look like this. And again, remember, I'm not coloring it all the way in. I'm just drawing enough shading so I know which side it is. All right, let's talk about the other one, which I'm going to do in red, pink, mauve, whatever it is. The boundary line is going to be y equals 2x plus 2. Notice that these have the same slope. Lines that have the same slope are parallel. My y-intercept is 2, which is right here. Using my slope of 2, here's the direction it's going to go, and again it's going to be dashed. So it'll look like this. And yeah, I could have gone off a little bit further. Now, do I shade above or below? 0, 0 for this one. Last time it was above, now it's below. Is 0 less than 2 times 0 plus 2, or greater than, I'm sorry, is 0 greater than 2 times 0 plus 2? 2 times 0 is 0, 0 plus 2 is 2. Is 0 greater than 2? No, it is not, so 0, 0 is not going to work for this one. Let's try something on the other side. Let's try 0, 3. And I got lots of choices, but I'm going to try 0, 3. Is 3 greater than 2 times 0 plus 2? 0 plus 2 is 2. Is 3 greater than 2? Yes, it is. So now I'm going to shade this side. All right, now remember the previous videos? We said that when the two lines intersect, we get 4 sections. Well, something weird happens when these two lines are parallel. The two boundary lines are parallel. I have this area right here, kind of like a neutral zone. Neither, with an I, come on. I'll try it over again. I'm going to write it right here. Neither of the two inequalities have points that solve it in here. For the green area, this is y is less than 2x subtract 3. For the red area, this is y is greater than 2x plus 2. There is no overlap. There's no place where the green overlaps the red. So this one, there's no solution. There's no point on this grid that's going to make both of them true at the same time. And sometimes that'll happen. It won't happen if the lines are not parallel. It could happen if the lines are parallel. What do you mean it could happen? I just saw when it didn't happen. Well, maybe it does happen. Let's see what happens. I keep saying happen a lot. All right, so here's my green one, G for green. Boundary line is y equals x subtract 3. That tells me that my y-intercept is -3 right here, and that my slope is 1. So it's going to go like this, and like this. That tells me it is a dashed line. When I have greater than it's dashed, this one's going to be solid when it has the or equal part to it. So let's draw my dashes. And do I shade above or below it? I'm going to try that 0, 0 again. Is 0 greater than 0 subtract 3? Is 0 greater than -3? No, it. Or actually, yes, it is. I'm sorry. Yes, it is. So I'm going to shade above this one. Let's try this point just to double check. Is 0 greater than 4 subtract 3? Well, 4 subtract 3 is 1. Is 0 greater than 1? No, it's not. So I'm going to shade above this boundary line. All right, I'm going to draw this one with red. The boundary line is y equals x plus 1. So my y-intercept is 1, and my slope is also 1. And again, I know that's the same as it was because these lines are going to be parallel in this example. So I'm going to go here, here, and I'm going to go this direction. Before I draw the line, solid or dashed, this is going to be a solid line. So let's see if I can draw that. And go in this direction. And make sure you draw it all the way off the grid. Now, ignore the green for just a moment. I have this red. Do I shade below or above it? Let's try 0, 0, which is below. Is 0 less than 0 plus 1? It is. 0 is less than 1. So that's going to be true. So I'm going to want to go below. Let's double check by picking something on the other side. Let's try 0, 2. Is 2 less than 0 plus 1? Is 2 less than 1? No, it's not. So I'm going to shade below. And look what happens. I get this. So last time, the shading went in opposite directions. This time, the shadings are going to go toward each other. So I still have 3 sections, but look what happens. In this red area, this is only y is less than or equal to x plus 1. In the green area, it's only y is greater than x subtract 3. But in this area right here between them, that's where both of them work, and that is the solution. All the points in this area between the two boundary lines, and even on this boundary line, those are going to work for both of them. Let's try one more with parallel lines. Grab my paper here, sorry. All right, so here's my green one. My boundary line is y equals -3x subtract 2. My y-intercept is -2. My slope is -3. That tells me to go down 1, 2, 3, and to the right 1. The next one's going to be down here someplace. So let's turn it around. It also tells me to go up and to the left. 1, 2, 3, left 1. 1, 2, 3, left. 1, 2, 3, left. So it's going to be about right there. Both of these have the equals part, so both of these are going to be solid. So let me draw my solid line here. And I can pick some points. Again, 0, 0. 0, 0 is nice. It's just nice. 0 is less than negative 3 times 0 subtract 2. Is 0 less than negative 2? No, it is not. So let's go on the other side. Let's try right here. Let's try 0, negative 4. So is negative 4 less than negative 3 times 0, 0? Is negative 4 less than negative 2? Yes, it is. So I'm going to shade below. Switch markers. My boundary line for the red one is going to be Y, and again, I'm only using the colors while I'm teaching this, okay? When you use your pencil or your pen or whatever it is, or when you use Notability, switch colors. That'll be fun. Okay, but if you're just doing this all by pencil, it's all good. Don't worry about it. I don't need anyone to like start searching for colored pencils or markers or anything, even though you probably have them. But I'm just using two different colors so you can see what happens here. My boundary line is y equals negative 3x plus 4, and it will be a solid line again. So my y-intercept is positive 4. My slope is still negative 3, which tells me to go 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, and also 1, 2, 3 up 1, or left 1, sorry, up 3, left 1. One more time, I know it's solid, so I'm going to draw my solid boundary line. And do I shade above or below it? So let's try 0, 0 again. That's below the red. Is 0 less than or equal to negative 3 times 0 plus 4? Is 0 less than 4? Yes, it is. So 0, 0 works. So I think I'm going to need to be below this line. Let's try something on the other side. Let's try x equals 2 and y equals 0. And you can try anything in here. They're all good. I just like staying on the axes because one of them is going to be 0, and that's easy to do in my head. X equals 2, y equals 0. Negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. Is 0 less than negative 2? No, it's not. So I am going to be below, and it's going to look like this. Okay, now that's weird looking. Let's talk about what happens here. In this empty space over here, neither of the inequalities have any points at our solution. In this space between the boundary lines, this is only the red one, which is y is less than or equal to negative 3x plus 4. But this area over here, that's both of them. So one of the cool things about this is that if I say what's the solution to this system, the solution to the system is just wherever the green stuff is. Because everywhere where it's both is just green. The red is in that area where it's both. The red has some extra stuff, but the green area just takes care of the entire system. So if you look, let's look at these real quick. Sometimes you get no solution. Sometimes the two boundary lines, the solutions point toward each other. And sometimes they point in the same direction, and it's the one kind of, this is a bad way of saying it, but it's the one that's kind of on the inside that actually takes care of all of it. Okay, we'll see you in the next video.